Hello, chemistry students. Today we are going to get into a brief introduction into organic nomenclature. This is essentially, nomenclature is basically what in organic chemistry, how you name different compounds. And it's a great way for helping to simplify the wealth that there is for organic chemistry. Since organic chemistry deals with hydrocarbons, molecules that deal with hydrogen and carbon, and there are a ton of examples. Now, in this case, for your class, we're just going to be looking at for this video, we're just going to be looking at alkanes. Now, alkanes are simply molecules that contain carbon bonded to either carbon or hydrogen. And we're going to deal with the first 10 alkanes and deal with the naming system of those, of what they mean. Now, for the first 5, here's what you should understand. When you see the name methane, that implies that your molecule only has 1 carbon in it. Ethane would only have 2 carbons, propane would only have 3, butane would only have 4, pentane would only have 5 carbons. In organic chemistry, when you're making organic compounds, you assume, if we're not dealing with an ion, you assume that carbon is bonded to 4 other elements, or is bonded 4 times. Now, in the case of alkanes, each of those bonds is a single bond. We're not dealing with double or triples. So, if you have a molecule that has either carbon or hydrogen, and you know that that molecule only has 1 carbon, such as methane, if carbon is bound to 4 other elements, then we assume those other elements are hydrogen. So, in the case of methane, where methane means 1 carbon, we assume that the other 4 bonds that carbon is bonded to are to hydrogen. Now, in the case of 2 carbons, well, we draw a single bond between each carbon, in the case of ethane, and then we draw for each carbon the remaining 3 bonds going to hydrogen. And what I'm showing so far is really the chemical structures. What we can see is that as we get onto more and more complex alkanes, it ends up becoming quite a bear to draw everything out. But first off, this case would be propane. Propan means that we are dealing with a molecule of 3 carbons. For alkanes, we simply draw each carbon, draw a single bond from 1 carbon to the next, and then we assume that the remaining bonds on each carbon are going to hydrogen. So, in the case of the leftmost or the rightmost carbon, the carbon would be bound once to another carbon, but then there would be 3 other bonds going to hydrogen, whereas the central carbon is already bound to 2 different carbons. Therefore, its 2 remaining bonds are going to 2 different hydrogen. Now, in this case, this is where I'm going to introduce a concept called a line structure. This is effectively a way of simplifying drawing all that hydrocarbon goodness. For a line structure, we effectively only draw the carbons as corners. And then, well, like in the case of propane has 3 carbons, therefore the line structure would be 1 dot, 2 dot, 3 dots, and then you're filling in the single bonds with those carbons. The line structure only represents the carbon skeleton. However, we assume that carbon is always bound bound 4 times. So, in order to save on space, we assume that those bonds that we are not showing are actually the ones that are going to hydrogen. So in this case, this carbon at the end here, represented in the line structure, would have 3 invisible bonds going out to 3 hydrogen, whereas the carbon in this top point, it's already bound to 2 carbons, therefore we have 2 hydrogens that are not being represented. So, line structure, it shows the carbon skeleton, and then you assume that if each point isn't already bound to 4 other things, or 3 other things, or 2 other things, you assume that the invisible bonds are going to hydrogen. Now, we can go on to another example, which is butane. Butane would be an example of a molecule, an alkane, which has 4 carbons in it. So, just drawing that out, drawing its chemical structure out, it would be 4 carbons in a straight row like so, and then we add hydrogen to each carbon until each carbon is bound 4 times to something else. To represent the line structure for this molecule, we have 4 carbons, therefore we are going to have 4 points. 1, 2, 3, and 4. And then we are simply going to just leave out the bonds going to the hydrogen, whereas this carbon right here would be this point right here. The 3 hydrogen attached to that carbon are just not being shown, but they are assumed. Now, the point right here would be for one of the internal carbons, which is bound to 2 other carbons, and then we have 2 invisible bonds to hydrogen. And then the same goes for the other 2 carbons. Now we also have the case of pentane. Pentan is simply meaning 5. 5 carbons are involved. So a straight chain alkane would simply be, or a straight chain alkane of pentane would simply be 5 carbons in a row, and then you just fill in the hydrogen until each carbon is bound to 4 other elements. And then the line structure would simply be 5 corners, each corner representing a carbon. Going from left to right, 1 carbon, 2, 3, 4, and 5. So that would be representing that molecule as a line structure. Now we are going to get into more complex alkanes. For example, let's look at the next set of 3: hexane, heptane, and octane. Hexane is a root word that means 6 for organic chemistry. That means that we are dealing with a alkane. Each carbon is single bonded, but there are 6 carbons in total. So if you see the word hexane, just know that that means 6. And to represent that as a line structure, ignoring the hydrogens, we have 6 corners. 1, 2, 3, 4, 5, and 6. Boom. Going on to heptane. Heptane would be 7. So for these alkanes, we are just dealing with straight chain hydrocarbons. So if you want to draw the chemical structure, you can simply just draw it straight out, or you can zigzag if you want, just as long as each carbon is bound to another one, and then you fill in the remaining 3 or 2 spots with hydrogen. And with heptane, if we're just going to write it as a line structure, then we can just represent the carbons as 7 different points. So 1, 2, 3, 4, 5, 6, 7 points like so. And then going on to octane would be a molecule, would be a organic molecule that has 8 carbons in it. That's what the octa stands for. And then the ane ending basically means that they're all single bonded. And to write the line structure of that molecule, well, it would be 8 points representing each carbon, a single bond between each point to represent the bonds of the carbons. And then we just leave out the hydrogens. And then the last 2 examples of alkanes, the last main 2 that we're going to have for this class, will be that of nonane and decane. Nonane would be an example of a carbon, that has, of a hydrocarbon that has 9 carbons in it. And, well, to represent that as a straight chain, it would be, or to represent that as a line structure, you would have 9 points, each single bonded to another point, and then you just leave out the hydrogens. So for this part of organic nomenclature, simply just do the last one, which would be draw the chemical structure of decane and also include its simplified line structure. Now, just to note, decane, it's a alkane that has 10 carbons in it. So there are 10 carbons, and then you have to fill in the hydrogens for the chemical structure or leave them out for the line structure. And that would be it for this part of organic nomenclature.